All right, so this is our last standard, which basically does operations with imaginary numbers. So all this really means is you have to try to pretend that they're x's, and that's pretty much it. The only weird thing about imaginary numbers is that I squared is worth -1. We talked about that in class last week, but all you're doing is treating them like x's. So this problem is pretty straightforward first, actually. The number out in front, whenever we see that separated by a parenthesis, we know that that is asking us to multiply. So 6 times 3 is 18 with the I. Repeat with the 6i and the -7i. 6 times -7 is -42. And I was multiplying I times I. Well, I times I is just like x times x. Well, x times x is x squared. So I times I must be I squared. So when I multiply 6 times -7, I got -42. But remember, I was also multiplying I times I, which is the I squared part. And also remember that I squared is -1. So we can make that substitution. In place of I squared, I can totally override I squared and replace it with -1. And then what I have here is a negative times a negative, which is a positive. So what I really have there is 18i plus 42, because -42 times -1 is 42. And that's my answer. I've performed the multiplication. I don't have any I squareds in my answer, so I'm done. If I look at this problem right above it, it's the same kind of thing. I just have to ask myself, what am I doing? And remember, when I see parentheses, I have to make sure that I look out front. And if I look out in front here, I'm just multiplying this by 1. So there's secretly a 1 here. And if I multiply 1 times 7, I get 7. 1 times 5 is 5i. So those parentheses actually didn't need to be there. They were just there to make the problem look pretty. You know, we organize things in math. So when you look out in front, make sure that you understand what number is in front. If there's a number in front, you should take care of that before you drop the bars. Same thing here. What I see in front here is a -1, and I need to multiply that -1 through these two numbers before I can drop the parentheses. So -1 times 9 is -9. -1 times -3 is a +3, but that 3 had an I with it, so it goes along for the ride. -1 times -3 is +3 with an I. And then I try to see if I can put any of these terms together. So 7 matches -9. So 7 minus 9 is -2. Again, if you don't believe me. 7 minus 9, see, -2. I guess I could split screen this for you. And then I'll do the same thing with the imaginary numbers. I've got a +5i with a +3i. So I'll just type in 5 plus 3 on Desmos, and that's 8. So plus 8i. I wonder if you can see the split screen. Hopefully you can, but maybe you can't, so I'll just take it off just in case. 5 plus 3 is 8. The i's had an I. And the reason that we don't switch the i's to an I squared here is because I'm grouping 5 and 3 i's together. So I'm not multiplying the i's. I times I is I squared, but I'm not multiplying I times I. I've basically grouped them together. So what I mean by that is there's like 5 i's over here and 3 i's over here. And instead of multiplying them, I'm just sort of pushing them together to be together. But when I put this pile of 3 i's with this pile of 5 i's, then what I really have there together is a pile of 8 i's. It's a little different. 5i plus 3i is 8i, but 5i times 3i is 15i squared, because I times I is I squared, just like x times x is x squared. And again, I squared is -1, so this is really -15. Adding is very, very different than multiplying. It adds a layer of complexity there. All right, let's do one more. 4 plus 9i squared, what that really means is I'm multiplying, just like 5 squared means 5 times 5. 4 plus 9i squared really means 4 plus 9i times 4 plus 9i. So if we multiply these together, first distribute the 4 to both terms. 4 times 9 is 36 with an I. And then repeat the process with this 9i. So 9i times 4 is another 36i. 9 times 9i is 81i squared. So let me break that down one more time. First, we do this problem by multiplying, by remembering that 4 plus 9i squared means 4 plus 9i times 4 plus 9i. And then you sort of have to pretend like this 9i isn't there and distribute. Basically multiply this times this, which gives me that 16. 4 times 9i, which gives me 36i. And then there's nothing else for this 4 to multiply in this parenthesis. So now I can basically ignore this one and repeat the process with the 9i and everything else. 9i, the first thing, like this first thing, 9i times 4 is this term here. And 9i times 9i, 9 times 9 is 81. I times I is I squared. So I might see or might notice that these two look pretty similar. And they're being added. So plus 36 plus 36, again, I can always use a brain or a calculator here, but 36 plus another 36 is 72. So what I really have here is 16 plus 72 i's plus 81 squared. Now I'm about to circle my final answer, but I want to just make sure. I can only circle my answer if I have combined my like terms, meaning are any of these combinable or are they all different? They all look different to me. This is alone. This has just an I and this has an I squared. So they all look different. So again, I'm about to circle my final answer, but wait, don't forget to check. Not only do you want to make sure that you're not grouping things together that are not the same, but you want to make sure that there's no I squareds. And remember, there is an I squared, and that I squared is worth -1. So 81 times -1. So basically what that I squared will do to this 81 is it'll turn it to a -81. Because a positive 81 with a -1 makes it a -81. And now again, I'm going to circle my final answer, but now that I squared has shown up, it's turned this thing, which was not combinable with the other things, into something that is combinable. So it's really important that we always make sure that there's no I squareds in our final answer and that we're replacing them with -1. Because if we don't, we might have something that does not look combinable when it actually is. So I'll just put in decimals one more time. 16 minus 81, which is -65. So if I take the two things in the bubbles, that's -65. And then bring down that 72i, because that one definitely is not combinable with anything else. And now I'm confident that my answer is good. These are not combinable. This has i's, this doesn't. There's no I squareds in my answer. And now I'm pretty comfortable. And hopefully this helps too.